All right, so today we're in section 8.6, scientific notation. There's a couple concepts. You do not have to write these down, but I need to go over them with you, okay? You don't have to write these down. It's going to be on the YouTube video for you to refer back to. It's also in your book, okay? Scientific notation is a shortcut to writing really big and small numbers. Here's what you need to understand. We are not changing the value of these numbers at all, okay? They still have the same value. We're just writing it in a shortened way. If there are 15 zeros after a number, that's a really long number to write. So scientific notation gives us a shortened way to do that. Powers of 10, so you're going to see that throughout the entire lesson today, that 10 is your base when it comes to scientific notation. And then we're going to do two formats, standard form and scientific notation, where our decimal value always has to be between 1 and 10. And there's something we can do to make sure that that always is the case without us having to do too much work. All right, so here's example 1. I want you to write down these 4 numbers, skip about 2 lines in between. All right, so when it's a really, really large number, like the top 2 numbers that you see here, okay? Top 2 numbers you see here, 173 million and 25 billion. We need to place our decimal from left to right. So we always scan these numbers from left to right. We need to place our decimal after the first number that is not a 0. Okay? So when it's the really big numbers, it's after the first number, 1.73. And what that does is it gives you a number that falls in the range of what you need. Greater than 1 and less than 10. That's the range that we need it to be in for scientific notation. Now what I need to do is I need to multiply it, again, powers of 10 because of place value. For each place value that increases, that's a power of 10. From the original decimal, we know is understood after the ones place, to the new one. All right, so guys, here's what you can do. Each number stands for a place value, so count your numbers. You don't have to do this thing, okay? You don't have to do that. Count your numbers between the old decimal and the new. There are 8 digits. Each digit stands for a place value, so that is to the 8th power. Okay? Now, let's go over to 25 billion. What is the decimal value that you need to use for scientific notation on the top right? 25 billion. What's the decimal value? Somebody tell me. What's it going to be, guys?
10.
No, the decimal value.
2.5.
2.5. And then my base, yes, needs to be a 10 because it's powers of 10. Now I need to decide what is my exponent going to be. Well, I'm not guessing. I need to look from my first original, if it's not there, it's understood after the ones place, to my new decimal after the 2. How many digits are in between?
10.
There are 10. So that means it is to the 10th power. Okay, and that's how I write a number in scientific notation. The decimal has to be greater than 1 and less than 10, multiplied by a base of 10 raised to an exponent. All right, so now let's look at the bottom 2. What you should notice about the bottom 2 is that instead of really, really big numbers, they are really, really small numbers. So anytime you see that, part of the process is still the same, meaning from left to right, I must put my decimal after the first number that is not a 0. So does that mean it can go here?
No.
That's a 0. I have to keep going until I get to my first number that is not a 0. Does everybody agree that 3.2 falls into the range that I need it?
Yes.
Greater than 1 and less than 10. Okay, so I'm good. Now I have to figure out from my old decimal to my new decimal location how many digits, and each digit stands for a place value, stand in between the two decimals.
6.
So it's 3.2 to the negative, times 10 to the negative 6th power. So the difference here, guys, and how I know it's a really, really small number is that negative exponent, okay? If that exponent is negative, I know it's a really, really small number. All right, let's look at this last one. Where do you think that decimal is going to go in the last one? There's something a little different about this one that we need to talk about.
Before the 7.
Is it before the 7? Is that the first non-zero number from left to right? 5. I get to my 5. If I put it after here, that's 500.7. That's greater than 10. I can't do that. Okay? I need to put my decimal after the 5, but can I just say 5? You're saying 5 point what? 0, 0, 7. Why do I need my zeros there? I didn't have a 0 on any other decimal value, but I have to have my zeros here. Well, it is. It's smaller than 10. But I had to have my zeros there because I had a number after the zeros. If I just drop it off, I'm changing the value of my number. I can't do that, okay? So this isn't this year. It was actually when I taught 7th grade. The book gave, and I'm just going to kind of jump over here real quick. The book gave us the number 1,000,005. And it said, write that in scientific notation. The point it was trying to prove is, as soon as you have a number at the end like that, it immediately locks in all those zeros in between. You cannot just drop off the 5. If you do, you're changing the value of the number, okay? So if I were to write that number, I would have to say 1.000005. So 2 practice problems real quick, then one more example. All right, Isaiah, what did you put for your first answer? 36,700,000?
3.67 times 10 to the 7.
Perfect. Do you agree with him? You should. That's right. What about the second one? Anybody get the second one? Anybody get the answer to the second one? What would be the decimal value? 6.4 times 10 to the negative 4th power. Very good. Okay, who got them both right? Anybody get them both right? All right, example 2. Okay, writing numbers in standard form. Now we're expanding. Okay, so standard form, another word for that is expanded form. If it's a positive exponent, do you think you're going to make the number bigger or smaller based on what you know so far? If it's a positive exponent, do you think the number is going to get bigger or smaller? What do you think? It's going to get bigger. And if it's a negative exponent, that number is going to get smaller. So without the exponent, I could take any decimal value and I could move it either way. I could make it bigger or smaller. The exponent tells me exactly what is going to happen to this number. If it's positive, that means the number is getting bigger by that many place values. Okay, so because this first one is a 5, that means this first number is expanding by 5 place values. Are you with me? How many place values are already in the decimal? How many place values are already there?
2.
There's 2. So if there's already 2, but I need to expand it out 5 decimal places, how many more zeros do I need?
3.
I need 3 more zeros. Now, guys, this part is so important. The commas, I see mistakes every year. So what you need to do is just write out the number first. You said there's already 2 that I can expand it without adding any zeros. I can go 1, 2, but now I need 3 more zeros to get it out, the full 5 place values. Now that I have my number written, I need to go back and put my commas in from right to left, starting in the ones place. A comma goes after every 3rd place value. So every year I have people going the opposite way, left to right with the commas, and that is not correct. So I just needed to remind you of that. All right. Go ahead and write this next one down. 4 times 10 to the 6th power. 4 times 10 to the 6th power. Do I already have some decimal values in here that I can count towards that 6? Okay. So the 6 tells me I need to expand this by 6 decimal places. Well, are there any in here? Do you see a 4 point anything? Hello, guys. Do you see any decimal values here? There are not. So that means I need to add in 6 zeros. There's none that I can count. So 6 zeros come into play. And 4 million is the expanded form. All right. So if there's a 4 point something, then those decimal values count when I'm expanding it. But if there's nothing, then I just go by the exponent. All right, here's one more. 2.2 times 10 to the 8th power. Okay, I need you to decide how that needs to be expanded, and check your answers with your table mates. Here's my question. Is the 8 telling me that I need to add 8 zeros? No, it is not, because in my decimal value, I already have one place that can move without adding any zeros. So if I can move 1, how many more zeros do I need to get out to 8? 7. So this is just write the numbers. 1, 2, 3, 4, 5, 6, 7. But this is not my final answer. Do I go from left to right to put in my commas? No, I go from right to left. If you go in the wrong direction, guys, sometimes that can mean a wrong answer. All right, 220 million. Who got that right? 220 million? Who got that right? Okay, most everybody. All right, so now let's look at the negatives, the negative exponents. Well, if it's a negative exponent, well, let's compare it to the left side. When it was a positive exponent, I put the zeros on the back side of the number to make it bigger. So where do you think your zeros are going to go for the negative exponent? They're going to go before the numbers. So that means if I'm moving left, I can count any place values that are to the left of the decimal. I can count as one place value that I'm moving. All right. Now, what tells me again, same thing with negatives, what tells me how many place values I need to move? No. The exponent tells me. So if it's a -3, that means I'm moving to the left 3 places. Well, if I already have 1, how many more zeros do I need in front of the 7? 2 more zeros in front of the 7. So I would just write my zeros first. Okay, and then remember, guys, you are moving the decimal. That's the whole reason why you're putting those zeros in front of the 7. Now, this is your answer. However, mathematically, when there are no numbers in the whole numbers, does everybody agree? Like your final answer, there's no values to the left of the decimal. What do you think you need to put there as a placeholder? A 0. Okay, that has nothing to do with your exponents. But when there's no values out there, you put a 0 to hold the place. Okay? All right, now I want you to look at the last one. How many zeros do you think need to go before the 8? Don't say it out loud. I want you to write it down, please. How many zeros would go in front of the 8, guys? 5. 0 point 1, 2, 3, 4, 5, 8, 3, 3, 4. Just don't forget your 0 placeholder. All right, who got 5 zeros in front of the 8? Who got that right? Okay, and that's it. That's where we're going to stop for today. I have shortened the homework through number 26 even. So hopefully it will not take you too long, and I will update the portal. And we'll pick up here tomorrow.